let us start with the Boolean retrieval. Okay, your syllabus will be Boolean retrieval, introduction, Boolean retrieval, indexing, that means your inverted file, and index construction, and index compression. So there will be 4 chapters. Okay, Boolean retrieval along with the introduction. Introduction is just few lines, hardly 2 or 3 slides for introduction. Okay, so introduction and Boolean retrieval, that comes under 1 chapter, and we have your second chapter, which is inverted file. Then after that, we have index construction and index compression. Okay, 4 chapters will be there for your midterm, and another 4 chapters are remaining. That will be your for your next end term syllabus. Okay, so first 4 chapters. Information retrieval we have seen, so we will directly start with your Boolean retrieval method. The Boolean retrieval. In Boolean retrieval, as we have already seen in our last class, so here we are going to use your Boolean logic and classical set theory. We will be using set theory and Boolean logic. Okay, and or, not, XOR, all those things, Boolean operations, we will be using in our Boolean retrieval method. So in information retrieval is normally normally retrieving some information from your database. So how we are going to retrieve? That is using certain techniques and certain methods. So first method which we will be seeing is Boolean retrieval method. So Boolean retrieval, it is based on Boolean logic and set theory. So here in this we will be coming across terms. The terms are nothing but your words. So they are usually words. So terms and information need is how we construct your query. Information need what the user wants. So what the user desires to know or what the user wants to retrieve, that comes under information need. And query, this is what the user conveys to the computer. So there will be a communication using the query. Okay, using the query, we can create a communication so that we can extract or we can retrieve what we want. Actually, the term should be retrieve. We can retrieve what we want, not extract. Okay, because information extraction and information retrieval are 2 different terms. And there will be document. So document will be piece of it contains some information, and from this information we can retrieve the information need. Okay, so this is some information. So from this information we can retrieve the information need. So these are some terms which you need to know before we go for Boolean retrieval. So AND operation, OR operation, NOT operation, we can use as a Boolean operations. Okay. So if a term is present in the document, it will be presented by 1, and if it is not there in the document, then it will be marked as 0. So zeros and ones. So our Boolean model will consist of zeros and ones. Ones if the term is present in the document, zeros if the term is not present in the document. So we have some input collection here. In this input collection, we have 5 documents. So all individual words, as you can see here, they are termed as terms. So English is one term, tutorial is one term, and is one term, fast is one term, track is one term. Similarly, for all the remaining words in the document, other documents, they are all terms. So now we will come to the example. So referring this input collection 5 documents, we will be initially constructing a term document incidence matrix. Term document incidence matrix. So this matrix consists of your terms and documents. Terms and documents. So either you can represent terms in the horizontal manner or terms in the vertical manner. So here terms we have written here vertically, documents we have written here horizontally. So with this we are going to represent all the terms using zeros and ones. So first we will check with English. So English is there in document 1. So English is there in document 1. Yes, so it will be represented by 1. Similarly, you check for English if it is there in document 2, if it is there in document 3, 4 and 5. So in all the other documents, English is not present, so it is represented by 0 here. And only in document 1 English is present, so we represent by 1. So likewise, we check for all the terms in the documents. So we have 5 documents here. So for all these terms, we have checked in all the documents and we have constructed a term document incidence matrix. And finally, the second part is to solve the query. What is our query here? Our query is advanced and structure and not analysis. Advanced and structure. So you have to perform an AND operation first for the term advanced and structure. And then we have to calculate not analysis. You calculate not analysis, you get a result here, and for this advanced and structure also, you'll get a result. So these two results, you have to perform again an operation. So finally, you have to perform an operation. So the first one is for advanced, the second one is for analysis. You have done the AND operation, so the result is here. And after that, for not analysis, this is the value for not analysis. So we already know how to write the not analysis, how to write advanced. So you can check here. For advanced, it is 0, 0, 0, 1 and 0. And for structure, it is 0, 0, 0, 1, 1. Perform AND operation. AND operation means only 1 and 1, it will give 1. All others will get 0. And for not analysis, where is this one? Not analysis value 0, 1, 0, 0, 1. Not analysis, you just invert this. So for not analysis, the value will be 1, 0, 1, 1 and 0. It is written here 1, 0, 1, 1 and 0. So you have to perform an operation, this value, these two values. Perform an operation. So only when 1 and 1, you'll get 1, others all 0. So 0, 0, 0, 1 and 0. So this 1, it means it is in document D4. It is present in document D4. Hence, for this particular query, our retrieved document is D4. So our retrieved document is D4. So this is how we perform an operation. So you can elaborate more on this, putting OR operation. So examples also we have discussed in our class. So here another same example but different query. We have AND operation, we have OR operation, we have NOT operation. Okay. So the same, this is the document. We have 8 documents here. Document 1 is also there, but it contains 0 documents. That means 0 information, no information at all, null. So, but D1 is there, which contains no information. So this is counting as a, we are counting this as a document ID. So we have written down here. Then perform an operation or operation. So the terms in the brackets should perform the operation first, and finally the result we have retrieved here 3 documents, D7, D5 and D2. Okay. Now this is, yeah, this is the example which we have solved. Here also same thing, we have 4 documents. Construct the document incidence matrix, and from that matrix you solve the queries. Okay, so this is about Boolean retrieval method. So this is the first method for information retrieval. Now coming to the second method. Second method is inverted index. Inverted index. So it is also known as inverted file or posting file. So let me say the screen. Okay, so indexing, this is another method for information retrieval. So here we are going to construct an inverted index. The index, as you all know, it's nothing but it contains some information with some specific tag. Okay, from that tag we can easily find where that particular information is. Okay, the document indexing is the process of associating information with a file or specific tag, allowing it to be easily found and retrieved later. So this is just like your index, which is there in your textbooks, um, any books and all. Initially we will have a index. So there, that particular chapters in the book will be tagged along with their page numbers, locations or positions. Okay, so if we want to turn up any particular page of the book, we will be first uh, referring your index. Okay, so chapter number 1 or chapter number 2 is there in which page number. And easily, instead of turning up all the pages, we are going to turn up only that particular position or location of the chapter. Likewise, we are constructing here inverted index. So inverted index is a database index storing a mapping from content to its location. So the content will be mapped to the locations in a document or set of documents. So how to build an inverted index? We have 4 steps here. The first step is to collect the documents. So your document may have some information and you may have more than one document. So for example, here Friends, Roman, Countrymen is one document. So Let It Be with Caesar is another document, and so on. You may have certain number of documents with more information. So for this example, we have just use these 2 documents. So more documents are there, but we are considering only 2 documents. Then tokenize the text. That means we are going to separate the terms. We are going to separate the terms. For example, here in this Friends, we have separated into a single token. Romans, we have separated into a single token. Countrymen. So, let, it. B with Caesar, and etc. Okay, so we have separated our document into a list of tokens. That is called tokenizing the text. And third step, we have to perform a linguistic preprocessing. So we have to perform a linguistic preprocessing. So how? Linguistic preprocessing can be done by producing a list of normalized tokens. So here, friend. Now, the actual term is friends. This has been normalized and we have put as friend. Romance, we have normalized and put as Roman. Countrymen, we have normalized. So, countrymen includes many people. So, that has been normalized and we have just put countrymen. So, like this, normalization of tokens will help you to identify the terms easily, because in the whole context you may have certain terms. Say friends may be there in document D1, in document D2 you may have only friend, like this. So both singular and plural form can be there in different documents. So instead of putting friends as one different token and friend is one different token, we have normalized, and by just taking it common, we have just taken, yeah, into a generalized or normalized term as friend. Similarly for romance also, we have normalized and we have put as Roman. Now the fourth step, that is about linguistic preprocessing, and the fourth step is about constructing the index. Okay, so index the documents that each term occurs in by creating an inverted index. So here we are going to create an inverted index which consists of dictionaries and postings, which consist of dictionaries and postings. So dictionary is nothing but your vocabulary, that is your terms, and postings is nothing but your locations. So postings indicate locations and dictionary indicates your terms. So our pictorial representation, you can see here documents to be indexed. Documents to be indexed. Now, some certain documents are here. They're using a tokenizer. We are going to normalize the token. Sorry, using a tokenizer, we are going to separate into individual terms. So, individual terms we have separated here, and performing the linguistic processing, we have put the friends into normalized token as friend, Romans into normalized term Roman, countrymen into normalized term countrymen, and finally creating the inverted index. So friend, which is there in document D2, which is there in document 4. Roman, which is there in document 1, 2. So this part is known as the posting list. Five. So here also you can see here this part, you can see these are known as postings, and your left side where you can see the terms Brutus, Caesar, Calpurnia. These are dictionary. So together posting files. The Brutus is present in D1, D2, D4, D11, document 31, document 45, and so on. Caesar is present in such and such documents. Calpurnia is present in these four documents. Okay. So this is how we create the inverted file. And also, we also can put your document frequency. So you can check here how to include document frequency. We have two documents here, document 1 and document 2. And this document one, doc1, we are just putting some document ID so that we can just put the IDs in your posting list. Instead of writing document 1, document 2, we can just put the IDs 1 and 2 in your posting list. So now all the terms are written in document D1 and the IDs are respective IDs are written, and after that we have just counted the document frequency of each terms. So document and all the terms must be sorted. Okay, it should be in the alphabetical order. The sorted document is the 1, 2, 3. The third column is your sorted document. So it is sorted, the terms are sorted, and the respective document frequencies are written. So as I already told, term frequency and document frequency are different. The term frequency is the number of terms. You have to count the number of terms in the documents. Whereas document frequency is you have to count the number of documents in which the particular term is present. And we have written ambitious. Ambitious is document frequency is 1 time it is present in D2. So in document D2 only it is present, it is not present in D1. Hence the document frequency for MGS will be 1. Then posting list, it is present in 2. That means D2, which is document 2. Similarly, for all other words, we have written the respective document frequency along with the posting list. So 1 second. Okay, now that is about index, inverted index. The same, we have done the example with 2 documents again. First come, first serve, last in, first out. For this, document frequency for first will be 1. Sorry, 2, because it is there in D1 and also it is there in D2. But when you say term frequency, it will be 3, because in D1 it occurs 2 times and D2 it occurs 1 time. So term frequency, when I say, it will be 3, whereas document frequency, if I say, it will be 2. So the same thing we have written down here for come. Document frequency is 1 since it is present in D1, and for all the other terms also we have written document frequency along with the posting list. And now here another important term. Just examples you can do by yourself. Processing Boolean queries. So processing Boolean queries, we normally perform intersection operation. So that means intersection means common to both. Okay, intersection operation, and it is represented by logical operator N, ANDN. Okay, Brutus and Calpurnia. So we are going to perform the intersection operation of Brutus and Calpurnia. So for that we need to locate the Brutus in the dictionary, and we have to retrieve the posting list of Brutus. So in which documents Brutus is present. So last part you see here, you can see Brutus is present in document 1, 2, 4, 11, 31, 45, 173 and 174. Similarly, for Calpurnia, we have to locate the California term in the dictionary and we have to retrieve its postings. So the retrieved postings are 231, 54 and 101. Finally, this two posting list you have to perform the intersection operation. That means common to both. So 2 is common. Document 2 is common to both Brutus and California posting list. And document 31 is common to both Brutus and California posting list. So after intersection, we retrieve two documents, document 2 and document 31. So this is the algorithm and this is for n terms algorithm and you will see only the examples. So for this also the same thing, the posting size has been given here. So this posting size you have to sorted it and you have to write separately. Okay, and after being sorted you have to perform the operations given in the query. Tangerine or trees and marmalade or skis and kaleidoscope or eyes. So the solve example for tangerine or trees, we have written it here. For tangerine, the sorted posting size posting list is 3, 4, 5, and 6. That means it is present in document 3, document 4, document 5, and document 6. And trees, it is present in document D1, D2, D3, D6, and D8. And perform OR operation. OR operation means you have to combine what the posting list. That means you should not, if any one of the term is present in the documents, you have to write all the document IDs all together here. So all these IDs has been written, but it cannot be repeated. Okay. So 3 it is repeated, you have just written 3 here. And 6 is repeated, we have just written 6 here. So tangerine no trees, the retrieve result is 1, 2, 3, 4, 5, 6, and 8. Similarly, you have to calculate for marmalade or skis, kaleidoscope or eyes, and finally you have to perform an operation of the results of these 3 OR operations. Now coming to tokenization we have seen here. There are various issues which we come across when we perform tokenization. You can see apostrophe and you can see hyphenated words and all these words will be very confusing when we perform tokenization operation. So, and even you can see here lowercase in this example, one is hyphenated, one is giving a white space and putting it all together. So all this lowercase and co-education hyphenated word, this is also hyphenated word, this is apostrophe, and San Francisco. So this is name of one place, but whether this will be one token or two tokens. So like this, there are issues in tokenization. So these issues can be solved using language identification. So we can handle all the issues using language identification. And we have stop words. Stop words are those words which are commonly used in the document but that has little value in helping to select the documents. So these are called stop words. And, a, are, was, where, of, that, for, from. So all these words you see here, these are stop words. So these are very commonly being used in the document, but they appear to be of little value when we go for retrieving the document. So token normalization, for example, these two words anti-discriminatory and anti-discriminatory will be mapped into anti-discriminatory. So when there is hyphenated word anti-discriminatory, so this second word can, since it is mapped, we can use as a token like this, anti-discriminatory as one token without hyphenated word. So when it is there in some documents, hyphenated word anti-discriminatory, with this we can read this one. So in other words, in other documents, if you find anti-discriminatory being written together, that also, since it is already mapped to this term anti-discriminatory, we can consider this as a single token. So if we map, then it will search for one term only. So anti-discriminatory only it will search, and it will retrieve the documents that contain both this hyphenated and not hyphenated words. And you can see down here query term and terms in document. This also windows. So you can just write window, and it will retrieve all other windows being written in capital window and being written with singular form. But here what they have written, the first one is for say for example, if window is your particular term in your this computer window, then we can just use capital letter with W. So like this. And windows, what does it say? This windows will retrieve this window. This windows will retrieve windows, and windows. Again, this window will retrieve window and this windows. So, what you can understand from this is the last window. The last window will be mapped with all the windows given here. And stemming and lemmatization is one important part here. The purpose for stemming and lemmatization bot is to reduce your inflectional forms of the terms. For example, say M, R, is, this is called the form of the verb. So for these three terms, you can just write B. And if there is apostrophe cars or cars and singular form cars, plural form cars, all this will be mapped to car. Okay. Then as a token, you can write this car alone. So when there are what cars, also this car will retrieve this cars. If you write, it will retrieve this. And singular form car also you can retrieve with this word. Cars also we can retrieve this word. Okay. So the result of this mapping, you can see one example given here. The boys' car are different colors. So it remains the same. Boys, it is mapped to boy, and cars, it is mapped to car. Are, since it is the be form of the verb, the base form is be, so be is written here. And different is other form of differ, so we write differ here. Colors, we write color here. So when a query is given like this, so it will be mapped to the statement like this. The boy car be differ color. And stemming is chopping off the end of the words. So like replacement, man, if you cut, if you chop off, then replace will be there. So like that, it removes your derivational affixes. Okay, it removes your derivational affixes. Lemmatization, lemma, bringing back to your base form of the verb. Base form is also known as lemma. You just go through these examples. You can see the token show. For example, for this particular show, if it is a noun, we can directly use show. But if it is a verb, then it will return to see, because the base form of the verb show is see. Okay, depending on the use of the token, whether it is a verb or whether it is a noun. If it is a noun, it will return as so, and if it is a verb, it will return as see. Okay, so stemming, which means chopping off the end of the words, and also it includes the removal of derivational affixes, and lemmatization, it's bringing back to the base form of the verb. Okay, so it refers to doing things properly with the use of the vocabulary and morphological analysis of words, normally aiming to remove inflectional endings only and to return the base or dictionary form of the verb. Return the base form or dictionary form of the verb. This is important. Okay. Okay, so for today, let us just do this revision for these two chapters, and remaining two chapters we will do the revision tomorrow for your midterm. There will be in total four chapters. Okay, Boolean retrieval along with the introduction. Second one is inverted file. Third one is index construction, and finally index compression. Four chapters will be there for your midterm. Okay. So before we end up, let me just take your roll call. Roll number one,
Present, ma'am.
roll number two,
Present, ma'am.
roll number three, Atul Sharma, absent. Roll number four, Torrentry, absent. Torrentry has been absent for more than 5, 6, 7 classes. Manikanta, roll number five,
Present, ma'am.
roll number six, Simre,
Present, ma'am.
roll number seven,
Present, ma'am.
Satyanarayan, roll
Present,
number
present,
eight,
ma'am.
Sagar,
Present, ma'am.
roll number